test I have coming up this week is on integration and taking derivatives inverse trig. The integration part, they're all going to be fractions or rationals. So I just wanted to give you some techniques that we had looked at along the way, because they won't all be inverse trig functions when you integrate. So you're always going to try a u du first. So if I'm looking at the first problem, I can see my u and my du will not match. So you can try it. If I pick my u to be x squared plus 2x, I can't subtract 2. Remember, it is you're multiplying by the width, and so I can't have this add 2 on there. So when I look at the fraction, it looks like I can reduce it by x. And so remember, that has to happen to each and every term. Now if I pick my u, it looks like I have a direct match. So I'm going to turn this into my u substitution, 1 over u du, which has a form natural log of the absolute value of u plus c. Next problem, you want to look again. I can't reduce that fraction. I can't split that fraction up. If I pick a u, it would have to be the denominator. And my du would not match either. So when we had something like this, when the powers in the numerator or the degree in the numerator was equal or larger than the degree in the denominator, we would do a long division. So I'm going to take x cubed and I'm going to divide it by x squared minus 4. So I'm going to multiply by x, and I get x cubed minus 4x. I need to subtract, and I get 4x. I can't multiply anything by x squared to get 4x, so that is my remainder. So this fraction just changes the way it looks. It's equivalent, but it's just going to change the way it looks. So I'm going to write it over here. I've got an integral of x, and I have a positive 4x being divided by x squared minus 4 and a dx. So the first term, x, I can integrate, and it's going to turn into x squared plus c. I'm going to wait with that plus c. The second one I can't reduce, but I believe in the second one I could pick my u to be x squared minus 4. My du is 2x dx. I divide by 2. It looks like I can have a match. So I'm going to pull out the 4. I'm dividing by this 2, and I have a du in the numerator and a u in the denominator. So again, that becomes a natural log. So sometimes a natural log is disguised as maybe possibly an inverse trig function. 4 divided by 2 is 2. Natural log of the absolute value of u. And don't forget your plus c. So remember, that plus c is the c from the red integral and from the original one on the x squared. Another way or technique that we've done was to separate fractions. So it looks like x squared plus 9 might factor, but remember, it is a positive 9, so it won't. So I'm going to make 2 fractions out of this. X is divided by x squared plus 9. And 3 was divided by x squared plus 9. The second one, I see immediately an inverse trig function of tangent. Tangent's one that occurs a lot. If I was to integrate that, the 3 would stay. This would be 1 over a arctan of u, and so my u over a. So you have to look at these. X squared, so my u is x, 9, and so my a is 3. And so that's where the 1/3 come in, and you can see that these are going to cancel. In the second one, I think I also need to pick a u. So my u is x squared plus 9. My du is 2x dx. So I've got this 1/2 that's going to come out in front. And I'm integrating a du over au. So once again, I get that natural log that comes in. So 1/2 natural log. I don't really need an absolute value here. Remember, logs have to be positive. Kind of showed that on the graph. And then I'm going to just get arctan of x over 3 c. In the second to the last one, number 4 here, I see an inverse tangent. So I see my u as x plus 3, and I see my a as a 2. So I don't even need a u du. I think I can directly just put it in there. So I'm going to get 1 over a arctangent of u over a plus c. And in the last one, when I try to complete the square on this, remember what I'm doing when I complete the square. It looks like I need 16. I only gave you 10. I'm just going to pull that 2 out. I only gave you 10 to make that square. So it looks like I had to go out. I needed to go get 6 more. And you might wonder where that came from. So I'll just kind of write it out here. X squared plus 8x. I needed 16 to make that square. And then I only had 10, so I have to subtract 6. But there's a problem with this. I have an error on the sheet. I don't think I can have a minus 6. It doesn't look like inverse tangent. I don't think I have a u du. So we're going to change this to plus 20. So if that was plus 20 and I needed 16, it would look like I would still have 4 left over because I've only used 16 of the 20. So if I'm looking at that integral now in a factored form, it again looks like the inverse tangent. U is x plus 4. Notice du is just dx. And my a is 2. So there's the 2 that I took out from the numerator. Here's the 1 over a. And then I've got arctangent of u over a plus c.